What's up, gang? It's your boy. How you doing? We're here with page 2 of homework 4, and we are going to be taking some vectors and splitting them into vector components. My favorite. All of these are actually going to be pretty simple. They're going to be solved in a very similar way. I want to remind you guys, though, that we're going to do a quick recap. With this, I'm going to assume standard coordinate play array, so that's plus, plus, minus, minus like this, where to the right and upper positive, down and to the left or negative, like you do on a regular coordinate plane. I'm just going to keep this in mind for if you wonder why my signs are positive or negative, why I'm putting a minus sign in front of something, that's why, in case I forget to mention it. So in all these, we're taking the vector and breaking it up into its x and y components, and we're going to do all of these exactly the same way. What you do to find the x and the y component is, first things first, you draw your two components in. You want to make a right triangle so that out of two straight lines that go to the tip of the arrow from the tail, usually you want to do this in a way that will encompass your angle. So you notice how I drew this kind of around this 30-degree angle here? That's how we do that. Okay, so that's how we do that, first things first. Second things second, we gotta make sure we know which is our x and our y. Of course, our horizontal lines are x's, our vertical lines are y's. That's how we're going to find this thing's x and y component. Now, first things first, we take the sine and the cosine of the angle. This will tell us the percentage that it exists in x and y. So in both of these cases, it's going to be sine 30 and cosine 30. Then, from the sine and cosine of the angle, we are going to multiply it by the length of the entire vector, or in this case, 27. This basically takes that percentage and then multiplies it by the whole thing. That tells you what the length of the two sides are. Now, the kicker is, we're going to take... have to figure out which of these is x and which of these is y. Remember, when you're in Leesburg, you touch your cosine. And I so passionately said that I bonked my camera. When you're in Leesburg, you touch your cosine. So the side that is touching gets cosine. Notice here how this 30 is touching the x side. It is not touching the y side. So it's going to be our x component, and then our y component is going to go to sine. So cosine goes to x, sine goes to y in this case. Alright, and now, all I have to do is put that stuff into my calculator. So I'm going to ask my calculator what the cosine of 30 degrees is. It'll give me 0.866. I'm going to multiply that by 27. And my x component is 23.38. I'm going to round it to 23.4. Now go to my calculator, ask it, hey calculator, what's the sine of 30 degrees? I believe it's 0.5. It is. Times 27 is going to be 13.5. So our y component is 13.5. That's in newtons. That's in newtons. These are in newtons because this is in newtons. So those are my two components, and we're done. Pretty easy. That's how you find x and y components. Take sine and cosine of the angle, you multiply it by the whole length. Let's do it again. Over here, we have... Make the triangle. First things first. This is the x, this is the y. This goes horizontally, that goes vertically. Okay, remember again, you want to draw your triangle so that you catch your angle in here. Alright, so we have sine and cosine of 15 degrees. The x side, again, is touching my angle. See how they're next to each other? So we can find this real good by... doing that. So the touching side is cosine, the non-touching side is sine. We can go ahead and multiply this by the length of the whole vector, which is 71. Bop, bop. Let's ask my calculator what this is. So the sine of 15 degrees is 0.26 times 71. This is going to give me about 18.4. So my y component is 18.4. And notice this is going down, so it's negative 18.4. I'm going to put a minus sign in front of it really quick. Cosine of 15 degrees, boop, is 0.97 times 71 is 68.6. So this side is 68.6. This is positive because it's going to the right. So my y component is negative 18.4. My x component is 68.6. Over here, this is 13.5. This is 23.4. Okay, another one. X and y component. So we're going to go up and up to block off our two sides here. Our vertical line is a y, our horizontal line is an x. Our x is going to the left, so it's negative. Our y is going up, so it's positive. I'll make myself a little note here. Okay, we're going to take sine and cosine of the angle, which is 45 degrees. Multiply it by the length, which is 125. And the side that touches gets cosine. The side that touches here is y. The y side is touching the angle. So y is going to get cosine, x is going to get sine. So we go cosine of 45 degrees, it's 0.707 times 125 is 83.4. And the x is going to be also 83.4, or negative 83.4. The reason, of course, this is 45 degrees, these are both going to be the same sign. It's times 0.707 for both of them. So they're both 83.4, but the x goes backwards, so it's negative. And that's how we find that one. Easy. Next one, x and y. Make the triangle so it's a round. Our x is a horizontal line, our y is a vertical line. Okay, our x goes to the right, our y goes up. That's going to be positive, that's going to be positive. You can tell by looking at the arrow direction, too, if you're ever confused by that. So then we can say sine and cosine of 35 degrees times the length, which is 45 newtons. Okay, so now that we've done that, we look at which side gets the cosine, which side gets the sine. The touching side is the x component, so it gets cosine, y gets sine. Remember, you gotta touch your cosine in Leesburg, Ohio. I'm so sorry. Alright, cosine of 35 degrees is 0.82 times 45 is going to give me 36.9. So this is 36.9. We can then take the sine of 35 degrees times 45 equals 25.8. So our x component is positive 36.9, and our y component is positive 25.8. Easy. Next one. Go down here. We want to trap the angle. So like this is how we'll do our sides. This side is y. This side is x. Y is going down. X is going to the left. So these are both going to be negative. I'm going to write myself a note to put a minus sign in front of them at the end. Okay. Sine and cosine of the angle, which is 41 degrees, which is multiply it by the length of the vector, which is 101. The touching side gets cosine. The touching side is y. Tig. My cat is trying to get into my room. He hears me talking and is sad that I'm not petting him. I will fix that after we finish this page, I think. So, hold on a minute, kitty. Okay, so sine of 41 is 0.66. We can multiply that by 101 to get 66.2 for our x side. So that's negative 66.2. And then our cosine side, we can say cosine of 41 degrees is 0.75 times 101 will give us 76.2. That's negative 76.2 is this side. So that's negative 66.2. That's negative 76.2. Those are our two sides. Nice. All right, last one on this page. We can go huh and huh for the x and the y component. The x component is the going to be the horizontal line. The y component is going to be the vertical line. This is going to the right, so it's positive. This is going down, so it's negative. We're going to take sine and cosine of the angle, which is 49 degrees. The touching side gets cosine, which is x in this case. And then we multiply this by the length, which is 23. So sine of 49 degrees, my calculator tells me, stop it, my calculator tells me is 0.75. We're going to multiply that by 23. 17.4. That was our y component is 17.4. Negative 17.4. And then our x component here is going to be cosine 49 times 23 is 15.08, which is going to round up to 15.1. So our x component is going to be 15.1. Positive. So our x component is positive 15.1, our y component is negative 17.4. So that's how we find x and y components from a vector and an angle. Pretty easy. Effectively, all you got to do is just make it into a triangle, catch the angle in there, Figure out what your x and your y side are. Take sine and cosine of the angle, multiply it by the length, figure out which one is which by remembering touching your cosine, then remember your sines, and that's all you have to do. So, good job, guys. I'll see you in the next page after I pet this cat.